Stanford University.
Okay, well, welcome to Stanford CS193P, Developing Applications for iOS. Winter 2017, this is lecture number 13. And this week's topic is going to be animation. And I'm going to talk first today about timers. A timer is just a way to execute a block of code some periodic amount of time. We don't really use timers for animation per se, but often when we're doing something that's animated, we'll have some timers involved, and you'll see that especially on Wednesday's big demo, how we're going to use a timer in with our animation tools. Then after we talk about timer and I do a demo there, we're going to dive into animation proper, and I'm going to talk about all the different kinds of animation mechanisms there are, and then dive into a couple of them with a bit of a demo in between, and then on Wednesday I'll do a demo of the last animation style that I'm going to cover. So timer is this very simple class, very simple to use. You're only probably going to use 2 or maybe 3 methods or vars in it ever, and all it allows you to do is take a closure, a block of code, and execute it sometime in the future, either once or repeatedly in the future. And this is kind of not really real-time programming. This timer is not going to go off exactly when you say, but it's going to be pretty close because it's going off on the main queue, and the main queue sometimes is busy handling an event or something like that. So it's not exact, but it's pretty darn close to going off. So you can't use it for real-time programming, but you can use it to have any kind of repeating thing going on. Now, timer is based on a technology which I'm not going to talk about called run loops. And run loops are how a certain thread gets all this information like events from the touch screen or events from the network or whatever. It gets all these things coming in, and it manages to hand them all out to whoever needs to handle them. And run loops aren't super complicated, but the reason I don't really talk about them is the run loop just kind of works on the main queue, and you don't really need to think about it. But if you ever find yourself, oh, I want to use a timer off the main queue, then you're going to have to teach yourself about run loops, okay? Because the timers are totally based on the run loops. But for your purposes in this course, as a starting iOS developer, you can assume that timers are a main queue thing, okay? Now, you can create timers by instantiating them, but then you got to put them on a run loop and all that. So there's really this one method, this class method you're going to use in timer. And what this one method does is it takes a block of code, a closure, and it takes when you want to execute it sometime in the future and whether you want to keep repeating executing it. And it goes and does that. It puts the thing on the run loop to make sure that it executes that block of code with that interval. Really couldn't be simpler. It's a very, very simple and powerful UI right there. So down at the bottom here is an example of it. This method is called scheduled timer, and it returns the timer that it creates when it schedules it and puts it on the run loop. And so here I'm just saying timer equal, I have a local var timer, notice it's subtype timer, it's optional timer here. And so I say timer equals schedule timer with time interval 2, repeats true, and in the block I put some code. Well, that's going to execute that code 2 seconds from now, approximately. And since it repeats true, it's going to execute it again 2 seconds later, and then 2 seconds after that until I stop this thing. Okay? Now, one thing to note about this little example here is notice my timer is weak. Okay, see that weak? Why do I make that timer weak? Well, when I schedule this timer and it puts it on the run loop is going to grab a strong reference to it. So I don't need a strong reference to it. And in fact, if I make my reference weak, then when this run loop is done with it, when this thing finally stops running, my timer var there will be set to nil. Perfect, exactly what I want, because there's really no use to having a pointer to this timer if it's not running anymore. And if I ever wanted to start a timer up again that I had stopped, I would just call scheduled timer again. It's such a simple API. So how do you stop a timer? So you got a timer and it's got repeating true and it's going off and it's doing this closure every 2 seconds or whatever. You stop it by sending the message invalidate to the timer. And so invalidate tells the run loop to stop scheduling this thing and invalidates the timer. Now, again, this timer is going to not, if you do a validate right there and you have a weak var to it, it's going to go out of the heap, which is really convenient. There's one last thing I'm going to talk about timers, which is tolerance. So this is not a real-time thing, and you might be quite tolerant of it not executing exactly on time. And this makes more sense for timers that take longer. Like, let's say you have a timer goes off every minute and it does something. Well, you might be happy if it goes off 50 seconds from now or 70 seconds from now. So you would set a tolerance of 10 on the timer, and it means it'll go off in the window plus or minus that 10. By the way, this does not have any drift. So if the system decided it was going to go off in 50 seconds this time, the next time it wouldn't be shorter and shorter and shorter with each time. So the time it goes off is the amount of time from the time you started the timer. Even if it's 2 days later, it's still going off once per minute. It's once per minute since you started the timer. It's just that when it goes off, it'll be plus or minus a little bit each time. Now, why would you want to tell the system this? Well, when your timer goes off, it might be that the system is actually asleep. Your phone surprisingly sleeps, takes little micro naps all the time, okay, to save power, especially to save battery. And it wakes up every once in a while, and it kind of knows when it's going to wake up again. And so the tolerance allows it to maybe take a micro nap a little longer because it's going to wake up for something else, and then it could do your timer. You see? So this is a little micro performance, but if you have something going off every minute over long periods of time, it can add up, okay? So that's tolerance. All right, so let's do a little demo. See this in action. It's kind of obvious once you see it. So I'm going to take Face It. Remember the Face It demo we had? This is a picture of a face. I'm going to make the eyes blink using a timer, okay? The timer's just going to open the eyes and then close the eyes. Open the eyes and close the eyes. Super simple. So let's go back and get Face It. Here it is. All right, so here is our face view now. The thing about the blinking, I want to show you this again because it's so important. I'm going to actually put this blinking code in a separate view controller, which is a subclass of the other one. So we have this existing face view controller right here. That's the thing that controls this MVC right here, okay, where this face is. It's loading up the face right now. And so I could just put this code in face view controller, but just to show you it again, this thing of subclassing another MVC to make one, I'm going to create a new face view controller called a blinking face view controller. I'm going to put all my blinking code into that. So let's just go File, New, File, and it's Cocoa Touch class, and it's a subclass of face view controller, and I'm going to call it blinking face view controller. And that's going to create a new class. I'll put it in the same place everything else is. Okay, here it is. Let's delete all the code in here. Again, just so as not to distract you. And you can see that it is a subclass of face view controller, which is this thing right here that has all our stuff in it. And all the code that I'm going to put inside here is only going to be for blinking. And I'm going to change in my storyboard. I'm going to select this MVC down here. And right now, its identity is face view controller, and I'm going to change it to be a blinking face view controller. And that change alone is going to make it so that this particular face view right there is going to blink. So how do we do that? How do we make this blinking face view controller work? Well, what's going to be its model? Well, its model is going to be public, and I'm going to call it blinking, and it's just going to be a bool whether or not we're blinking. Okay? And if someone sets this model of this blinking controller, then I'm going to call some method like blink if needed. Okay, and so blink if needed, private func blink if needed, is just going to blink if needed. Now, if blinking is false, obviously the blinking is not needed, so we won't be blinking. But if it is blinking, then we need to blink. Now, just for demo purposes right here, or maybe this is even what I would want, I'm going to turn on my blinking when I appear, when my MVC appears on screen, and I'm going to turn it off when I disappear. And you do need to think about this when you're using a timer, that when your MVC goes off screen, because it's in a navigation controller and someone navigates to something else, or someone hits back or something like that, you want to make sure that you stop your timer. You don't want that timer sitting there running, doing something. The MVC is not even on screen, unless it's doing something, I guess, that's not UI based. But I'm going to say here in my view did appear, super view did appear. I'm going to say here blinking equals true. So every time my MVC appears on screen, it's going to start blinking, and in view will disappear. I'm going to say blinking equals false. So I'm going to stop blinking when it disappears. That make sense? Okay, so that's going to obviously cause my timer to stop going because my timer is only going to be going when I'm blinking. All right, so how am I going to implement blink if needed? Well, it's only if needed, so I'm going to say if I'm blinking, then I'm going to do something. That's the if needed part of this blink thing right here. And what do I need to do? Well, first of all, I'm going to just have some constants here. I think I called it, what did I call this? I don't know what I called the constants here. Well, we'll just type them in. So I'm going to have a little struct here called blink rate. And I'm going to have how long my eye stays closed when I'm blinking and how long it stays open when I'm blinking. So let's have a static let closed duration, which is going to be a time interval. Time interval is just a little class or a little type that represents elapsed time. It's pretty much a double, but whenever we're talking about time intervals, we kind of let people know in our code by using the time interval type. And then I'm going to have the same thing, open duration, which is going to be a time interval. And you know, usually when we're blinking, our eyes stay open a lot longer than they're closed. So let's say something like, I don't know, 2.5 seconds, or something like that. Okay, now if I was doing this for real, I'd probably have the amount it stays open be random within some tolerance, right? Because when we're blinking, we don't go blink, blink. We, you know, kind of sometimes we blink and then this short amount of time. But again, for demo purposes here, we'll just fix it to be 2.5. All right, so we have that. Now, all we're going to do to blink is we're going to start by setting our eyes to be closed. So I'm going to say self, I don't even need self here, face view dot eyes open equals false. Remember, face view is one of our superclasses vars. It's a public var in our superclass. That's maybe unfortunate it has to be var or public. It would be nice if it was protected, maybe. We have no such thing. So it's a public outlet there, and we're setting its eyes open to false. So we're starting our blink by closing our eyes. Now, after the closed duration, we want to open them back up. So I'm going to say timer.schedule timer. And notice I'm not even looking at the return value of the timer because I never have to invalidate it. This is going to be a one-shot deal, and it's going to automatically invalidate itself when it's done. And so the time interval here we want is blink rate dot closed duration, right? We just closed our eyes. Eyes open equals false. And it repeats false. It's just going to do it once. When I'm going to call blink if needed again after I've blinked once. So I'm going to kind of keep calling blink if needed until blinking is not true anymore. And then here's the block of code that it's going to call each time. And so it takes a timer as an argument there. Oops. Timer. And we can use a closing, trailing closure syntax notation here to put that on the end. So here's the timer. So what do we need to do inside this timer? Well, we're just going to open our eyes back up. So faceview.eyesOpen equals true. And of course, we're inside a closure here. So we're going to need self dot. And of course, we don't want to have a memory cycle here, although this timer is so short duration, probably that's not going to be an issue, but we'll go ahead here and do weak self up here and just do question mark. Okay, so now eyes are back open, right? And what do we need to do now? Well, if we're still blinking, we need to blink again. So we basically need to call blink if needed again, but we got to wait for our open duration. Leave our eyes open for that long, and then if we're still blinking, then we'll blink again. So we'll blink if needed again. So I'm just going to do another timer inside here, which is perfectly fine. Even though I'm in a closure that's being executed 0.4 seconds in the future, there's no law that says in that closure I couldn't schedule another timer, which is exactly what I'm going to do. And this one, the blink rate open duration, so I'm just going to wait the amount open time. Again, it's not repeating. Okay, and then in this guy's closure, which I'm also going to do with trailing closure notation, timer, and heck, let's go ahead and do weak self. We know we're going to want that. In here, I'm just going to say self.blink if needed. And of course, it'll stop blinking if blinking has been set to false at any point here. Okay, so this is always going to do one blink, and then if it needs to, it'll go back and do another blink. So, oh yes, question mark is this weak. Everyone got this code? So that's it. That's all we need to do to blink. We're just going to open, or we're just going to close the eyes rather, wait a little bit, open them back up, wait a little bit more, and then blink again if we're still blinking. So let's see what that looks like. Okay, there he is. He's blinking. Okay, and he'll work. Here, let's switch him around. He works no matter what. Whether he's happy or sad, he's always blinking. Now, one thing about this blink that's not so good is it's kind of abrupt. That's why I'm saying it's not really animation, right? We don't blink like this. Okay, nobody blinks like that. Okay, we kind of close our eyes a little bit slow. There's a little bit of motion to it, and so we'd really like to do that. And so let's talk about some more animation capabilities we have and how we can do really more true animation of that than just using a timer. So let's go back to our slides here. All right, so before I do that though, let me talk about and summarize, not all actually, but most of the animation capabilities that you get with iOS. So the one I am going to talk about in detail and demo today is animating UIView properties. There's only a few of the properties, vars in other words, in UIView that you can animate, but they're a pretty powerful few as you're going to see, and allows us to do a lot of animation. There's also, you can also obviously animate those controller animations, like in a navigation controller when you click to go to the next card on the stack, it slides in, right? That's animated. And when you rotate your split view, those are animated transitions. That's all controllable. And in fact, even though I'm not going to talk at all about it in this class, might be a good final project not covered in lecture thing for you, by the way. There's a whole infrastructure for writing your own controllers of controllers, like navigation controller, split controller, tab bar controller. And so part of that mechanism includes full animation support. Now, underneath all of this animation I'm talking about is core animation. It's a framework, okay, like UIKit is a framework. And core animation has a lot of mechanisms for doing very sophisticated animation. Now, not a lot of it bubbles up to the UIView animation that we're going to talk about, but kind of the simplest, most straightforward ones do. Again, this is something for your final project. Maybe you want to do some more sophisticated animation. You could drop down into the core animation layer. There's a little bit of a window into core animation from UIView. It's a var in UIView called, I think it's called layer or CA layer, but it's of type CA layer, CA being core animation. And you can use that to kind of dive into core animation from a UIView. That's a little hint there. There's a lot of mechanism for doing 3D animation. OpenGL, there's a full OpenGL implementation on iOS. And there's also this layer Metal, which is this kind of powerful graphics layer, mostly for people writing really powerful, sophisticated animated applications. There's another cool little kit, you might put this in some of your final projects, called Sprite Kit. Sprite Kit is kind of 2.5D animation, a typical animation where you have like a little character running around and he's jumping over things and shooting at things. That likely would be done with Sprite Kit. It knows how to do things like fire and things like that, in addition to know how to layer images on top of each other and have them move around. So that's kind of fun. Not going to be able to talk about that. And lastly is physics-based animation. And we're going to talk all about that at the end of this lecture, and then I'll demo that on Wednesday. So the two I'm going to talk about is the first one and the last one, UIView animations, and then physics-based animation. All right, so let's talk about this UIView animation. What can you animate? Well, these are the things you can animate. You can animate the position of your view, so you can make it animated, moving, sliding around on screen. The view is moving around. You can animate its transform, which primarily means its size or its rotation, okay? Because the translation part of the affine transform, you're pretty much going to do with frame or center, okay? So you can rotate your view or scale it up and down. There's alpha, okay? Alpha, remember, is opacity, so how much it's transparent, so you can have things fade out into oblivion or fade in. And then, not very useful, background color. You can animate the changing of your background color from one color to another. Now, this UI animation of these vars is done using a class method in UIView that takes closures. And inside these closures, you're going to change these values, okay? And what the class method is going to do is animate those changes that you make. All right, so let's take a look at one of these class methods. This one's called animate with duration. And you can see that it takes these two closures right there. You see the two green closures. And the first green closure there, inside there, you change any of those special vars. Okay, frame, center, alpha, et cetera. You change them. By the way, it makes those changes immediately. It does not take time to change them, even though it takes time for it to appear on screen. It happens immediately. And then the completion block is called after the animation is done. So, you know, however long your animation is going to take, when it's completely done, then this gets called. And the finished variable there, the finished argument to that closure, is whether the animation got all the way to the end. And why might it not get to the end? Some other animation might pick it up in the middle and start animating that var to somewhere else. Okay? So here's what it looks like to call that. Here's an example of it. So here I have a view called UIView. And what I'm going to do with this code right here is I'm going to take a view as long as it's fully opaque, fully visible on screen. I'm going to wait 2 seconds, and then over 3 seconds, I'm going to fade it out, fade its alpha down to 0. And then when it's fully faded out, I'm going to remove it from the view hierarchy. Okay, that's what this code does. So you can see, at first I'm checking to see if my view's alpha is 1, so if it's full power. And if it is, then I'm doing animate with duration. The duration is 3 seconds. That's how long it's going to take the green code there to execute, not to execute, but to show up on screen. And then delay is how long I'm going to wait till I start the animation. The options, we'll talk all about options in a couple of slides, but here curve linear means it's going to go from alpha 1 to 1.0 in a linear over time. So after 1 second, it's going to be 1/3 of the way there. After 2 seconds, it'll be 2/3 of the way. And after the full time, it'll be down to 0. In animations, you can see what I'm animating. I'm changing the alpha to 0. Okay, that's the change I'm making to those special vars. And then in completion, you can say if $0, which means if I finished, then remove this view from SuperView. And remember that completion, that block is only called after the animation is done. In other words, 5 seconds from now. All right? Now, what's really interesting is on the next line there, I say print myView.alpha equals the value of myView.alpha. That is going to immediately print 0. Okay? That method, animate with duration, it only executes the first green closure there, myViewAlpha equals 0, and then it returns immediately after that. And at that point, myViewAlpha is 0. The animation is just queued up to happen in the future. So always think of the changes you make with the animation system as happening right now. You're just executing that closure right now. But by putting in this little wrap of this animate with duration, you're queuing up an animation to show the user that change that you've already made over time. And now it seems a little weird because it's like, whoa, I changed it right now, and so inside my code, alpha is 0, but the user still sees it fully opaque, which they do. For 5 seconds, it's still going to be opaque until it completely fades out. But that's just the way this works. You just got to get used to that. The animations always happen after the fact, over time. Okay, but the changes you make happen immediately. All right. Here's some of the options we can do when we animate. I talked about the curve linear, which is at the very bottom. Right above it, you see curve ease in, ease out, and curve ease in. These basically make it so that instead of just linearly going from the start value to the end value of that var change, it starts off slowly, then goes up to normal speed, and then slows down at the end. Now, why do you want this? This is especially good for moving. When you're like moving a view, you don't want a view to be on screen and go, beep. You want it to kind of go, and then slow down at the end. It just feels, if you move something in real life, you don't jerk it up here. You lift it up and then you set it down. Same thing here. You want to lift the view up, move it over, and then set it down. Okay, so that's why curve ease in, ease out. So you can control whether it eases on either end. Going to the one on the top, begin from current state. Remember I said that that finished argument to the completion handler would only be true if the animation got all the way finished. Well, if you issue another animation while this one's, like the previous one's still in flight during that 5 seconds, if you issue another one that changes alpha in some other way, well, either that animation is going to start from the new value of alpha, which is 0, okay, even though it's still in flight and hasn't shown that 0 to the user, it still is 0, or whether the animation of the alpha, the new animation, is going to pick up wherever the other one is. Okay, so in other words, is it going to pick up mid-flight and make the alpha go somewhere else? So that's what begin from current state says. Should I look at what the user perceives or is seeing as that alpha, or should I just use the real alpha, which has already been changed to 0? Okay? So you can look through the documentation for all these options. I think there's 25 of them, so there's a lot of cool things you can do there, and we'll talk about some more of them with some of these other UIView animations. All right, so that's the UIView animation where you're animating one of these 5 special vars. So there's another thing you can do with UIView animation is what if I have a view and I'm going to change a whole bunch of things about it, not just those special vars. I'm going to redraw in a different way, and I want to animate that whole change on screen. And there's a number of ways you can animate it. One, you can animate it by flipping over, so kind of like a playing card would flip over from the old view, make all your changes, flips over, shows the new one. Another one is cross dissolve. Okay, the old one's showing and the new one dissolves in. Okay, another one is curling up. So the new one is kind of in the back, the old one sitting on front, and the old one kind of curls up like a piece of paper and shows part of the new one in the back, which is kind of fun. That transition really only makes sense if you're covering the whole screen. It wouldn't make sense to have a curl up be in just like a view inside another view. If the whole screen was a view, you want to curl up and make sense. Okay? So this is entire view contents animation, not just those special things. It's done with a class method. It's called animate with, and transition with, not animate with. And transition with takes the view that has all this stuff you want to change, duration obviously, some options like whether you're curling or cross dissolving or flipping, and then the animations. Now in this case, the green animations can change anything about the view, not just the 5 special things, but absolutely anything. So that's what these animations are going to do there. And then the completion is the same. Okay, when the animation is done, it tells you. So what's an example of this? Let's say I'm making a poker game and I want to show a playing card flipping over. Okay, so let's say I have a playing card view, my playing card view right there, and it's got some var on it, card is face up, and if card is face up is true, then I get to see, you know, the king or the ace of hearts or whatever, and if the card is face down, then I just see the back of the card. So I've got this view, and I've got it currently in one state or the other, and I want it to flip over and show the other state. Well, here all I do is I do transition with my playing card view. I'm going to do it in 3/4 of a second, so it's going to be a pretty fast flip over. I'm using the option transition flip from left, which takes to the left edge and flips it over. And then inside animations, I'm just changing that card is face up var, the thing that controls which one my view is showing. And so this is going to flip over and show the card in the other direction. Okay? So that's cool. That's when you want to change the whole view. But you're limited in what kind of, you know, animation you can do, just flipping, dissolving, and curling up if it's full screen. All right, there's another kind of change to views you want to make, which is a change to the view hierarchy. So this means you want to put views in or take views out of the view hierarchy or replace one view with another. So this method is transition from to. So the from view is the view that's going to be leaving the view hierarchy, and the to view is the view that's going to be coming into the view hierarchy. They don't have to be in the same place, by the way. They could be in different places on the screen. That's absolutely fine. Usually they are in the same place. And this animation, here you notice that there's no animation block, because implicitly what you're doing in this animation is replacing the one view with the other, going from one view to another. So you've got the new view all set up the way you want, presumably, and you've got the old view, and you just transition across. Now, sometimes you don't want to actually remove these from the hierarchy, you just want to show and hide them. And so if in the options you put .show hide transition views, then instead of remove from superview and adding subview, it will just set the .hidden. Remember, view has a .hidden var that'll hide it. And it'll set 1 to hidden and 1 to not hidden. All right? I don't know, maybe that property is called is hidden these days. Yeah, anyway. All right, so those are all ways to animate views. So let's look at doing a couple of those in Faceit. So first I'm going to do the animation where we change the entire view and do flipping or cross dissolving to cause the blinking to be a lot smoother. And what I'm going to do is I'm going to take the two eyes in my face, replace them with views that draw the eye, and then I'm going to have the view change from open to closed, doing a flip from top. See how that's going to make it look like the eye is blinking, because it's going to flip over. That little circle is going to flip over like that. And then we're going to shake the head. This is a 2D face, so it's going to shake his head side to side instead of like this, because it's only 2D. And we're going to do that with the thing where we're going to change one of the special vars. The var we're going to change is transform, because we're going to rotate our entire face. Okay, so let's do those. Let's go back to Xcode here. All right, so to do the eye blinking, we need to have the eyes not be drawn. So right now, if we go to, if we go to our face view right here, you can see that we draw our eyes by doing this UI Bezier path, right? And then down here, if you remember in draw, we get the path for the eye and for both eyes, and we stroke it. So we're not going to do this anymore. Instead, we're going to add two eye views, which I'm going to show you in a second, as subviews of this face view. So we're not going to do that, and we're not going to need this. Actually, I am going to grab this center of eye out of here, because I still will need to put my new eye views somewhere, and that knows how to do it. So the rest of this, though, I'm just going to comment out. Okay? So we're not using that mechanism for drawing. Instead, we're going to eye view. Now, in the interest of time, I'm going to drag this eye view in and show it to you. So we'll copy it in here. All right, so what does this eye view look like? It's super simple. It has line width and color too, just like the face does. It has eyes open, which is a bool, either true or not. And then its draw rect, just if the eyes are open, it uses an oval Bezier path, which is actually a circle. And if the eyes are closed, it just does move to line 2. Okay, this is pretty much the exact same code that was in the face view. And then here it's setting its line width, setting its color, stroking color, and then stroking it. Everyone understand what this does? Any questions about this code? Super straightforward, all right? So we need to fix our face view over here to use those eyes, those eye views instead. So how are we going to do that? It's really just a matter of creating these eye views and then putting them in the right place. All right, so let's start with creating them. So I'm going to have a private var. I'm going to try to say left eye equals create eye, and then have a private func called create eye, which returns an eye view, let's say. Okay, and we'll return it. Now, I want to do this, but it's not going to work. Does anyone see what's definitely not going to work about a line of code that's like this? Okay, what am I doing here? I'm initializing left eye, right? And am I allowed to call a method on myself before I'm fully initialized? No. Okay, so that's why that's not going to work there. And you can see that the error is cannot use instance member create eye because property initializers run before self is available. That's exactly what we think here. So a fix for this is to make this lazy. Because if you make this lazy, it's not going to actually run. This initialization is not going to run until we're fully initialized by definition, because no one can call this left eye. No one can access this until we're fully initialized. So that's great. Now, this doesn't work either. Okay, and why doesn't this work? This doesn't work, because, and maybe we'll even see an error here. Yeah. Let's see. Yeah. Okay, so you see it says cannot use member create eye. When you do lazy vars, you need to specify the type. Okay, so you need to say, you have to explicitly type. You can't let it infer the type. So that thing. Now, there's still a problem here, another problem. It's saying here, use of instance member create type on face view, type face view. Did you mean on a value of face view instead? And in fact, exactly we did. It's trying to find a static function called create eye, right? A static function. But we don't want that. We want an instance one. And the way we specify that is with self. Self says, I want create eye that's on an instance like this, not one that's static. Okay? So that can be a little complicated right there to go through that, but just to know this is a way to get around having to write an initializer, for example. But you have to remember to do, explicit typing here, and you better remember to say instance, and it has to be lazy. All right, so we have the create eye. How do we create this eye? Well, I'm going to let the eye equal an iView. Now, obviously, I'm not providing a frame, so I'm going to have to set its size and position here sometime. Notice my eye is not going to be opaque. That's because if my face was blue or something, I would want that blue to show through. I wouldn't want it to be opaque, and so this eye is going to be completely transparent except for the parts that I draw with non-transparent colored ink, basically. I'm going to set my color equal to the same color as the face. I'm going to set my eye's line width to be the same line width as the face. Remember, these are just vars here in the face view, right? Color, line width, color. And I'm also going to just add subview, this eye, because I'm a face view. I'm going to add this subview as a subview of myself, and then I'm going to return the eye because this is a create eye, returns the eye thing. Okay, everyone understand this little method? Quite simple. I'm just configuring this eye, okay, and I'm using it for the left eye and for the right eye. Now, what about positioning the eye? Because there, I didn't say where this eye is. Okay, so right now I added it as a subview. It's in the upper left corner, size 0, 0, so that's no good. So let's create a private func here called position eye, and it's position eye. Oh, hello. Position eye, yes. And it's going to take an eye, which is going to be an eye view. And it's going to take the position to put it, where to put it center, which is going to be a CG point. And we need to get the size of the eye. Well, the size of the eye, remember, depends on the size of the face. So in a big face, the eye is big. In a small face, the eye is small. And if you remember, we have these nice little skull radius constants. So I have this ratios skull radius to eye radius. Remember that? And I'm going to make it 2 because here I'm talking about the width and height of my view, and the radius is only radius, not diameter. So I'm having to say times 2 there. So now I know how big this little eye view needs to be, and so I'm going to say eye.frame equals CG rect. For now, we'll have the origin be CG point.0. I'll put it in this center right here in a second, but right now I'm going to make the origin 0. And the size is a CG size where the width is the size and the height is the size. It's square. Okay, and now let's just set the eye's center equal to the center there. Okay, equal sign right there. Okay, so this little guy right here is just going to position the eye. Now, when do we want to position that eye? Okay, now this is very important. When we're in a view controller, we know when our bounds of our top-level view changes because we get view did layout subview sent to us. Remember that? If we're a view, this face view is a view, not a controller, a view. It gets told whenever its bounds changes by being sent the message layout subviews. Okay? So layout subviews is sent to all views when its bounds changes or any time that its subviews need to be relayed out. And that's exactly what we want here. We got to relay out those eyes. We got to move those eyes to their current position. So what is that position? We're just going to say position eye. We'll do both eyes. So let's do the left eye first. And to get the position of the eye, we have this nice method, center of eye, that we pulled out of the thing we commented out here, path for eye. It knows how to calculate the position of a given eye. So we'll just say that the position here is center of eye. And we'll say we want the left eye in this case. That. Is that all right? Did I miss something? Oh, sorry, this is position eye, center. Okay. So there's our left eye. Now let's do our right eye. Okay, everybody got that? So every time our bounds changes, we get layout subviews, we're going to move those eyes to wherever they're supposed to be, the center of eye thing. Okay? We got an extra argument. Oh, I guess I made that be that. Yeah, that makes sense. Okay? All right, what else do we need to do? Only one other thing we need to do is that remember that the eyes want to have the same color and line width and whether or not they're open as the face. Okay, so all these places up here where we set eyes open and where we set the line within color, we need to forward that on to our left and right eyes. So let's do it here for color first. Let's go down here. Now for color, we still need set needs display because other things in the view besides the eyes are a certain color, the mouth, etc. But we do need to say that our left eye's color equals this new color, and also our right eye's color equals the new color. And exactly the same here for the line width. We want to say that our left eye's line width equals our line width, and our right eye's line width equals our line width. And probably most importantly, when the eyes are open and closed on our face view, we want to have that set in our views. Now, notice that for here, we don't need set needs display anymore because we don't draw the eyes in our draw rect. See in our draw rect down here? We commented that out. We don't draw the eyes. The eyes are drawn by these two subviews that we added with add subview there. So here we can get rid of set needs display. And instead, we're just going to say left eye dot eyes open equals eyes open, and right eye dot eyes open equals eyes open. Okay, see how we're just forwarding that on to those two views. All right, any questions about that? Let's go to make sure we haven't broken anything here by making our eyes be separate views. Our view should, overall, our face view should look exactly the same. It's just using subviews to draw part of itself rather than drawing it in draw rect. And sure enough, it's working fine. It's even continuing to blink because that blinking is done by the controller. The controller is setting eyes open, eyes closed, eyes open, eyes closed, and that's being forwarded on to the view and it's blinking. Now, of course, we haven't changed the animation, so it's still kind of this insta-blink. So now we want to use the UIView animation to make that blinking a lot smoother. So how are we going to do that? Let's go over to our iView right here. And every time eyes open is changed, instead of just changing it, we're going to animate that change. So we are going to instantly change it, but we're going to, on screen, it's going to be animated. All right? So to do that, I'm actually going to make eyes open be private var right there. And I'm going to create the public eyes open, which is a bool. And this thing is going to be the thing that does the animation. Okay? And because setting this eyes open does the needs display, which causes this, I still want all that functionality. It's just that when someone publicly sets my eyes open, I want to animate the change that's going on there. So how am I going to do this? All right, when someone gets whether the eyes are open, I'm just going to return the private eyes open. Right? And if they set this eyes open thing, I'm going to say if the new value does not equal eyes open, so in other words, they've changed it. You know, the eyes, they didn't say eyes open and eyes are already open because I don't want to animate the changing from open to open. I only want to animate changes when it changes. I'm going to do this UIView.transition with view. Okay, not this one. I want transition with view, not from to, which remember is removing things from the view hierarchy. This one is transitioning inside a view. And so I'm going to do self as the view. This is the iView. The duration, I should make a constant here, but I'll just say 0.4 to make this expedient. The options I want to transition from top to bottom, okay? Because an eye blink kind of comes from the top. Okay, so we'll do that. And then here are the animations we're going to do right here. And I don't actually need this completion because I'm not going to do anything when it's done. Notice that that's an optional closure. You see how it's got a question mark on the end of it? So I will just not include that whole thing. All right, so what do I want to do in here? In here, I want to make all the changes to the view that I want to be animated. Well, here, it's super simple. I'm just going to set my underbar eyes open to be the new value. Right? We're in set here, so new value is whatever someone said eyes open equal. So here I'm just going to set it to the new value. That's going to change my view to the new eyes open state, and I'm going to animate getting to there. All right, so let's take a look. This guy should still be blinking, but he should be blinking a lot smoother, you see, because it's animating the actual motion of the eyes closing. Got that? And again, works in all All right. Now, the next thing we're going to do is have this guy shake his head. So I'm just going to rotate the entire view. Okay, he's going to shake his head by going a little to the left, all the way back over to the right, and then back to the middle. That's going to be shaking his head. Okay, it's the best I can do in 2D right here. So how are we going to do that one? We're going to do that one by animating one of those special vars in UIView, which is the transform. So let's go. We're going to do this in our face view controller. Okay, so this is going to be something that is kind of all faces can do. So we'll put it in there. Let's put it right in here, I think. It's good space for it, some room. And I have some constants for this, head shake constants. So angle is just the angle I'm going to turn to the left and the angle back to the right. And remember that we're in radians here, so it's 0 to 2 pi to go all the way around the circle. So I'm going to go pi over 6, which is a little bit around the circle. Okay? And then segment duration is how long I'm going to take to do each turn to the left, back to the right, and back to the middle. Okay? Each of those is going to take, in this case, half a second. So before I write the animation code, I'm going to make a nice little private func here called rotate face by. And it's going to take a CG float, which is radians, number of degrees to rotate the face. And it's going to rotate it. And the way we do this is just we take the face view's transform. Okay, remember we're in the controller here, so face view is a var of ours. And we're going to make it equal to the face view's transform rotated by that amount. Okay, let's make this a little nicer. We'll say by angle. Okay, so this is just a nice little function that rotates the face any amount of degrees. And I'm going to use this inside my animation code to rotate the face. Everybody cool with that, what that code does? So transform right here is an affine transform. Rotated by is just a method on CG affine transform. And you can look at the description there. It basically just rotates the transform. So that rotates the view, since I'm saying the face view is transformed to that. All right, now let's make a function that rotates the head. And it's going to rotate it left, right, and back to the middle. So I'm going to call this func shake head, because it's going to shake the head back and forth. And it's going to be animated, so I'm going to say right off the bat, right, UIView animate. And the one I want here for animation is this one right here, because I need the completion. Why do I need the completion? Because the way I'm going to make this rotation happen is I'm going to rotate to the left, and when it completes, I'll rotate to the right. And when that one completes, I'll rotate back to the middle. So do you see why I need to know when each rotation is completed? So that's why I need this animate with duration that has completion at the end. Now, this one it also has completion, but it has options. We don't need any options. We're just going to use standard animation. We're not going to ease in, ease out, or any of that business. Okay, so this is the one we want. Just to make this a little more readable, I'm going to do this little trick that I often do, just so you can see each argument one by one. So the duration of a tilt is the head shake dot segment duration, okay, that constant that I put up here. The animations, okay, this is what we're going to do to cause this animation to happen. Well, we're just going to rotate the face. Now, this first rotation is the rotate to the left. And in iOS, different from Mac OS, by the way, in iOS, positive values of angles are counterclockwise. So we want a positive angle because we're going to the left here. So I'm going to make this be my head shake angle. Okay, it's going to rotate by the head shake angle. That's going to head it off to the left there. Now, when it's done here, this completion code, which has finished, whether it's finished or not, and I do want to wait for it to be finished. Actually, I'm going to, I'll put this inside here just to make this a little easier for you to see that this is the completion. Okay, so that guy there and that guy there. Okay, so this is the code that happens when it's completed, and if it has, self.rotate. By the way, do we need memory cycle breakage here, etc.? No, because we're in the middle of an animation. Okay. That view controller is on screen. We do not have to worry about creating memory cycles here because we know that thing is going to be in the heap because it better be in the heap because we're animating right now. So this is a case where we don't really need to do weak self and all that stuff. All right, so when it completes, we're going to say if it finished, which it should because I'm not issuing any other animations here. But one day, maybe I'll add some new animation, in which case I might interrupt this. But so it's always good to check finished, even if you're 100% sure this thing is always going to finish, which we are in this case, as our code is written now. So if it's finished, what I want to do now is animate going back over to the right. So I'm just going to UIView.animate with duration again. Okay, and again, I want the one with completion here. Okay, and this time I'm going to do the same amount of time to go back to the right. So that's head shake. You could imagine that maybe this duration would want to be different since I'm going farther, but actually I think it's probably right to have it be this way, as you'll see. And these are kind of constants you can play with to make your head shake look like the way you want. And here are the animations. I'm going to rotate my face back the other way, so it's going to have to be a negative value. And I want to go twice as far, so I'm going to do head shake.angle times 2. Okay, I'm going to go all the way back past the middle and over to the right. And then here for the completion here, I'm going to, again, line this up so you can see it a little better. So inside the completion here, I'm going to rotate back to the middle. So yet another, in fact, watch this. Copy, paste. Although with this one, I don't need a completion one at the end because I have completed it. And here, obviously, I'm not going backwards. I'm going forwards again, which forwards is counterclockwise there. All right. That's everything there. And what else do we got here? Oh, whoops, forgot a curly brace there, comma. What else? Oh, we're missing some curly braces or something. Yeah, what do we got here? Oh, this is finished in. Oh, that's it. Oh, no, no. What else we got? This doesn't match anything. No, it does. Matches this. Okay, hold on. Anybody see where I'm missing a animations? Oh, another curly brace missing right there. And I do think we're going to need a curly brace there. Okay, lots of curly braces in parentheses there. We're doing it, we got it. Okay, so everyone understand what's going on here? So just shaking back and forth. You know, I know that's going to finish because I don't have any other animations going on that might interfere with it, but to be correct, I should probably always put that if finished in there, if that's what I intend. Sometimes I'm going to do something even if it doesn't finish, but in this case, I do want it. All right, let's take a look at this. And this is a very interesting combination of animations going on here, as you're going to see. All right, so, oh, sorry. Let's make some action cause it to shake its head. Okay, let's do taps. Right now, if we tap, it blinks the eyes, but we already got a blinking guy right now, so we don't need tap anymore. So I'm going to go up here to tap, right here, this tap recognizer. And I'm going to comment this out, and I'm going to show you a different way to do gesture recognizer. Did I show you how to do gesture recognizer directly in the storyboard? I don't think I've shown that yet, so let me show you how to do that. It's really easy. We're going to go to our storyboard right here. And this will actually show another cool thing. So here's my MVC. I'm going to bring up my assistant editor so that I can connect to it. And you're going to see that it brings up blinking face view controller. Now, I want to make a connection to a gesture recognizer here. I don't want it to be in blinking face controller. I want it to be in the superclass. But it knows that this MVC right here is a blinking face view controller, so it's trying to automatic show it to me. So how can I get face view controller here, and am I allowed to hook up to the superclass? And the answer is you are allowed to hook it up. And the easiest way to do it is to hold down Option, the Option key, and click on it over here. Because Option means open it up in the assistant editor. So now I have the face view controller here, and so now I could wire up a gesture to that. All right, so how do I wire up a gesture from my UI without typing code like all this stuff right here? And the answer is we go to the utilities window and search for gesture. And you'll see that there's quite a few gestures here that you can do. Tap gestures, pinch gestures, rotation, swipe gestures, etc. And you just get the view that you want here. Let me zoom in on it some. So you got this face view right here, and you just drag the kind of gesture you want, like a tap gesture, on top of it. And that's going to make this view recognize a tap gesture. Now, where did it appear? It appeared right here at the top. And I can click on it and inspect it over here, actually. I could set how many taps we want, how many fingers we want to go down, all that stuff we do in code, we can do it here. And then how do I get this tap gesture to actually do something in my code? Well, I just control drag, of course. So I'm going to hold down control and drag from this tap gesture in here. I want an action. Okay, it's going to be tap gesture as the argument. I'm going to call this also shake head. Same name, but this one has the argument of the tap gesture recognizer. Okay, everyone see that? How to hook up a gesture in the storyboard? It's pretty simple, actually. I prefer, actually, to do it in code. And why do I prefer to do these gestures in code like this? I just find that those gestures that are in the storyboard are a little hidden. They're up in that tiny bar up there, and I don't really notice them sometimes. I kind of like to do this, but it's personal preference, really. There's nothing wrong with doing them in the storyboard. Some people would say that's better, because then everything is in the storyboard. It's really easy to see what the gestures are. Either way. All right, so here's our shake head gesture. What are we going to do? Well, we're going to shake head. All right, we're just going to call this animated one up here. Ready, got that? Let's clean up our white space a little bit here. All right, so let's run this time. Now we can tap on our face, and it should shake its head, left and then right and back to left. Or sorry, left and then right and then back to the middle. All right, so here we go. This guy is blinking. Okay, it doesn't, again, matter what kind of guy he is. And let's tap. Oh, he went the other way. So I was wrong. I always get this wrong about which way is which in iOS. So actually, I guess positive values are, yes, clockwise, I guess. I think the documentation is backwards on this, and if I remember correctly. They might have fixed it. But anyway, so we go forward and then back. Now, a couple interesting things to note here. Look at our other animation. It continues perfectly happy. It does not care that we're rotating this view. It's completely irrelevant to that. And that's the way animations work. As long as they're not touching the same values, they can work completely independently. Another thing to note here is this is a subview of this view, and when I transform it, it moves all the subviews with it, which is kind of cool. Okay, so even if you build a view out of subviews, then if you animate it, rotate it or whatever, the subviews will get rotated as well. All right, everybody got that? All right, that's all I wanted to show you. So that's the power of UIView animation, and I didn't even show you a lot of the cool things you can do, like moving views. Okay, having views move across the screen. And the reason I didn't show you that with this view animation, it's pretty obvious how you would do it, but also because on Wednesday, I'm going to be showing you a really powerful way to move views across the screen with this physics-based one, which is the next thing I'm going to talk about in the slides. All right, let's hop back into the slides. All right, so dynamic animation. Now, this is a different approach than the UI-based animation I just said. In this case, what you do is you set up all these physics, like gravity and things like that, and then you just put the UI views in there, and they get affected by those physics, and they move around. Okay, that's the fundamental way to do it. Now, how do you do it? What's the mechanism for doing it? First, you're going to want to create an instance of this class called UI Dynamic Animator. Okay, a UI Dynamic Animator is a thing that controls all the physics-based animation in a view hierarchy. Okay, and we'll show you how to create that in a second. Then you're going to add what are called UI dynamic behaviors to that animator. And as soon as you add a behavior to an animator, it will start behaving that way. And then finally, you're going to add UI dynamic items, which are usually UI views, 99% of the time, to those behaviors. And then those behaviors will start acting on those views. So that's it. It's a three-level thing. You got the animator, you add behaviors to it, those behaviors start happening, you add UI views to the behaviors, now they start being affected by the behaviors. You can do it in any order. You could put the views in the behaviors first and then behaviors in the animator, whichever you want to do. So how do you create a UI dynamic animator? All it needs is the coordinate system it's going to work in. Okay? So UI dynamic animator, its constructor here takes an argument reference view. This is just the UI view whose coordinate system is going to be the coordinate system for all the animation that we're doing. Now, the views don't have to be, all the drawing doesn't have to be in one view. It can be in a whole bunch of views, but they have to be in the same view hierarchy, and you're going to want reference view at the top of that view hierarchy. Okay? That's the only restriction there. So now you start adding behaviors. So you do that by creating concrete instances of UI dynamic behavior, in other words, subclasses of UI dynamic behavior that do what you want. So there's a gravity behavior, which creates what seems to be gravity pulling the views, or a collision behavior where the views run into something like the edge of the screen or another view and they bounce off, okay? And we're going to talk about all these dynamic behaviors and how we configure them in a minute. And then the UI dynamic items. One thing to note about the UI dynamic items is that if you add, let's say you have item 1 and item 2, like in this example right here. I've added item 1 and 2 to the gravity, so they're both affected by the gravity behavior, but I only added item 1 to the collider. Let's say it's a collision behavior, and let's say there's a boundary at the bottom. So let's say the gravity goes down and there's a boundary at the bottom for the collider. Items 1 and 2 are going to accelerate down towards where the gravity is pulling them, but then item 2 is going to keep on going, and item 1 is going to bounce off the boundary, okay? So if you don't add the UI view to a certain behavior, it won't be affected by that behavior. Now, these items that you add to behaviors implement this protocol called UI dynamic item, which UIView already was implementing, okay, before they even invented this, because all that's in the UI dynamic item protocol is bounds, which you just get because your bounds are affected by your transform. And so you get your bounds so you know where to draw. And then the center and the transform are things that can be set. So the animator really can only change where the view is and its rotation and scale. Okay, that's all that the animator do. But that's a lot. Okay, rotation and scale, you can see, especially center, where the thing is a lot of what the animator is doing. Now, one interesting thing is once you add a dynamic item to a behavior that's been added to an animator, then the animator has control over its center and transform. And if you want to change the center and transform without removing it from the dynamic animator, you've got to tell the dynamic animator, hey, I changed this. Otherwise, it's going to change it right back to what it thinks it is. Right? So don't fight your dynamic animator if you want to change the center or transform of a view that you've added to an animator. You have to tell the animator using this method right here, update item using current state. And you just pass the UIView that you changed the center or transform of, and it will pick up what you changed it to and continue from there. All right, let's talk about some of the specific behaviors. There's gravity behavior. So gravity behavior, it's just like gravity. And by default, when you create a gravity behavior, the gravity is down, which means kind of down towards the home button, basically in portrait mode. And its magnitude is 1g, okay, 1.0. And 1.0 means 1,000 points per second per second. Remember that gravity is an acceleration. Okay, hopefully you all at least have enough physics to know that. Gravity is an acceleration. Anyone know what the gravity on Earth is? 9.8 meters per second squared, right? So on screen, it's 1,000 points per second squared. And what's really interesting about 1,000 points per second squared, it's a very round number, but it feels a lot like 9.8 meters per second squared. Now, if you have your phone, you put a view at the top, and you apply this gravity behavior to it, it'll fall almost exactly the same as a real-life object would fall. It's really pretty amazing, actually. And yet it's such a round number like that. So you can tweak these numbers, though. You could have the gravity be up. For example, when I pull out my phone and I swipe up from the bottom, okay, feel free to do it if you want right now. When you swipe up from the bottom, the little control panel comes up, it kind of flies up. That's actually using this mechanism, and it's gravity up. So gravity is actually pulling that thing up when you swipe. And what's more, when it hits, you notice it doesn't just come up and stop, it kind of bounces a little off the end. Okay? And that's a collision behavior. So that thing coming up is a combination of a gravity behavior and a collision behavior, or it might be using a snap behavior, which we'll see in a second too. So anyway, that's gravity, and you can set gravity in any direction. We're going to do that in our demo on Wednesday quite a bit. Another one is an attachment behavior. This allows you to take two dynamic items or a dynamic item and a fixed point and attach them at some distance apart. And how would this play out? Well, let's say I had a UI view and I attached it to this, a center point. And let's say that UI view, in addition to being affected by this attachment behavior, was also affected by gravity. Then it would come down and swing like a pendulum. Okay? Because the attachment behavior would be constantly attaching it to this point, but the gravity would be constantly trying to pull it down and it would swing. Do you see? So that's an attachment behavior. The attachment behavior, one thing that's really cool about it, you can change the length of the attachment in real time. So the thing is animating, and you can be changing the distance that it's attached. So you can create all kinds of crazy motions using that. All right, collision behavior. So collision behavior is exactly what you think. You can set up collisions. The collisions can either be between all the items that are in the behavior, they're being affected by the behavior, and or any number of boundaries. And these boundaries are just UI Bezier paths. So you can register these UI Bezier paths with the collision behavior, and all the items that are affected by the behavior will bounce off of those boundaries. Okay, and they can be round, they can be curved, they can be any path that you want. A common boundary, by the way, to want to put is a boundary all the way around the reference area, just to contain all the items inside. And you can do that with this var translates reference bounds into boundary. If you set that on a collision behavior, then it will kind of automatically put a boundary around the edge to keep everything inside the reference bounds. Now you notice the argument here, these boundaries have identifiers so that you can tell which ones you hit when they hit, and I'm going to show how you find out about that in a second. But you notice the identifier is an NS copying. Okay, you've never seen NS copying there before. NS copying, for the purposes of this, basically means NS string or NS number. Okay, so the identifier could be a number or a string, but they're these NS's. Now, that's no problem because you can just as them to a string or to an int if you want to use ints as your identifiers. But you do have to do that as. So NS copying is basically NS string or NS number. Now, why do you need that identifier? Because when a collision happens with a boundary, the collision behavior has a delegate, and it'll tell you. So if you set yourself as the collision behavior's delegate, then if you have any boundaries set in there, or if two items are colliding with each other, you're going to get this sent to you. This is a collision delegate method. Collision behavior began or ended contact for some UI dynamic item, a UIView that's bouncing around in there, with the boundary identifier NS copying. So there's that identifier telling you this boundary that you sent is doing this. And it'll even tell you the point at which those two things collided. If it's talking about a collision between two UI dynamic items, then it'll say with UI dynamic item instead of with boundary identifier. Okay, so this is really cool. When the collisions happen, you get to find out that they happen. And again, we're going to use that in our demo as well. All right, snap behavior. So a snap behavior is basically move this view from here to over here behavior. And why it's called a snap behavior is it doesn't move it over there really jerky and kind of stiff. It moves it over, and when it gets there, it's almost like four springs are attached to the corners, and it kind of vibrates a little bit. It flies over there, probably eases in, then eases out, and then when it gets there, it kind of shakes a little bit. Okay, like there's springs in the corner. And you can set the stiffness of those springs with damping. So highly damped, they'll come in and just stop, and really springy springs, they'll come in and go, kind of really bounce around when it arrives in there. So why do we do that? Because when we move things across screen to a new place, in real life, we don't want it to feel so abrupt, right? When we move things again, we want it to feel smooth. And so Snap 2 is definitely the way to move something to a known place with the system. Similarly, there's something called a push behavior. A push behavior gives a UIView a push. Okay, so we already know how to make the UIViews accelerate towards somewhere with gravity. Push is almost like imparting a velocity to it. Now, there's two kinds of push. There's instantaneous push, which is just one-time push, okay, imparts a certain energy to it. There you can see magnitude 1.0 is 100 by 100 view would get 100 points per second squared, kind of push to it. But then there's also continuous push, which is you're just pushing along behind. So that's velocity. Okay, you're giving the thing velocity because you're just constantly pushing it at some rate. So you can do both things there. One thing that's really annoying about push behaviors is the instantaneous ones. You add the behavior to the animator, right? And then it pushes it, and then it just sits there doing nothing. Okay, it doesn't like disappear after your instantaneous push, even though you're not going to push it again. So we want to clean that up, and I'm going to show you towards the end of this talk how we would clean up those instantaneous pushes, but it is a little bit annoying that it does it. Now, continuous push is different because it's constantly pushing, so you don't want it to be cleaned up. You want it to be sitting there pushing. There's another kind of behavior, which is kind of a meta behavior, called a dynamic item behavior. Okay? Dynamic item behavior, not dynamic behavior, dynamic item behavior. And this I like to think of as the physics behavior. This is essentially describing the physics that apply when all the other behaviors do stuff. Okay? So this is things like allows rotation. That's saying, like, if two things collide, should they be allowed to spin off, or do they have to keep, you know, non-rotated, bounce off non-rotated? Friction, after things bounce off each other, or if they're just moving around, do they get slowed down by friction? Okay, so if you have gravity and there's friction, they're not going to accelerate as fast because they're being slowed down. Elasticity, when things bang into each other, do they bounce off with the same energy they had coming in? That would be elasticity 1.0. Or do they gain energy by a collision? That would be elasticity above 1.0. Or do they lose energy as they collide each other? That would be elasticity less than 1.0. Okay, so you see how it's a behavior, just like a collision behavior, or a gravity behavior, or a push behavior, but it's a behavior that's like meta. It's like describing how this thing should behave in all the other behaviors. This behavior also can tell you the linear velocity of an item, which is actually interesting to know. Now, why do I want to know linear velocity of an item? A lot of times, if I've got a view, an MVC, and it's animating, and then I click away from it, like a tab bar, or in a navigation controller, I push something else on, I want to pause that animation. Well, there's no real way to pause. Okay? When your view goes off screen, when your view controller disappears, you're going to want to remove the behaviors from the animator and stop animating, because you don't want to be animating not on screen. Okay? It's a waste of energy. But when you go back to the view, you want all of the animated things to continue as they were. Well, they will, except for they'll have lost all their velocity. So you have to put their velocity back. So you grab all their linear velocities, store them away somewhere, and when you come back, add the linear velocity back. You could also use the linear velocity here to put a speed limit on objects. If we have time on Wednesday, which I doubt we'll have time, but if we can get to the speed limit feature, by the way, we're building like a space game where we're flying through asteroids. Okay, that's what we're going to build with this thing. So maybe we want the asteroids to have a speed limit where they just aren't going so fast, there's no way our ship could possibly dodge them or whatever. So we use linear velocity for that. So you can ask any item that a dynamic behavior is behaving on, you can ask for its linear velocity. Okay, now here's all these behaviors. Okay, gravity behavior, push behavior, all these are all subclasses of a class called UI dynamic behavior. Not dynamic item behavior, that's the previous slide. This is UI dynamic behavior. Now, a UI dynamic behavior is something you often create your own subclass of. Now, how the heck, you're probably like, what? I'm going to write my own gravity thing or my own collision thing? It's too complicated. And the answer is, you're right, it's way too complicated. So your subclasses of UI dynamic behavior, what they're going to be is composites of other dynamic behaviors. So if you had some space where there's boundaries and gravity is applying to things and they have a certain friction and elasticity, you would combine a gravity behavior, collision behavior, and UI dynamic item behavior into your subclass of UI dynamic behavior. And the way you combine them is with this very important method in UI dynamic behavior called add child behavior. That means composite this behavior into my behavior. And we almost always do this. Okay, create our own subclass of UI dynamic behavior and put all our other behaviors that are related in it as child behaviors. It's just a good way to collect the total behavior that's being imparted to things into one place. And we're going to do that in our demo as well. Most of the code we're going to write on Wednesday is going to be in a big UI dynamic behavior subclass, because we're going to put a lot of behavior on our asteroids that are moving around. They got to bounce off the ship, and they got to be affected by the ship's acceleration and all kinds of things. We're going to put that all in our own subclass of UI dynamic behavior. Otherwise, you generally don't subclass UI dynamic behavior, because that's really a subclass of UI dynamic behavior is mostly to composite things together. All behaviors of any kind know the dynamic animator that is currently animating their behavior. Okay, remember I said there's this UI dynamic animator at the top. You add all the behaviors to it. That thing, all the behaviors know the one they're in. They have a var called dynamic animator, which could be nil because they might not be currently being animated, that tells them that. They also find out with this method will move to dynamic animator every time they're either removed from a dynamic animator or added to a different one. They can only be animated by one. Sorry, they can never be animated by multiple dynamic animators. That would make no sense. They'd all be fighting each other. So this is just telling them the one that they move to. So you can find out when they move to. Why do you want to know this, by the way? It's sometimes very interesting to know when you leave a dynamic animator. Okay, because maybe you have something else going on, like in our demo, if we get to it on Wednesday, we'll have a little timer that's going on all the time. But if we're not being animated, we don't want that timer going. So we'll start and stop that timer in will move to animator. Okay? Okay, UI dynamic behavior also has a really cool var called action. Action is just a closure, takes no arguments, returns no arguments. This action closure is called every time this behavior acts. Okay, so collision behavior, when it collides, it's going to call this action thing. Gravity is calling this thing all the time because gravity is always accelerating the items more and more. A push behavior, it's called, if it's instantaneous, it's called when it does its one push. If it's continuous, it's going to be called all the time as it pushes on the thing. So these little closures are called a lot. So don't do anything expensive inside an action closure. Okay, you want to really make this code. If you go into instruments and you look at your code, if you do something expensive here, it'll come to the top pretty fast because it gets called a lot, as you might imagine. And, but you can do a lot of really cool things in here. For example, this is where you would implement your speed limit. Okay, check the linear velocity. If it's too fast, you would add some negative linear velocity to slow it back down. Okay. It's really easy to get memory cycles with this thing because, of course, this action var is a var in a behavior, and a lot of times inside the closure, you're going to be referencing the behavior, doing something about the behavior, right? So they're going to point to each other rather directly there. Now, another thing that's interesting about dynamic animator is it usually, most of the time, runs to stasis. Okay, so things are happening like, again, swipe up from the bottom of your phone, the thing, gravity pulls it out, it bounces off the top a little, and then it stops. And when it stops, okay, the animator's still on, but it has nothing to do, you'll get these delegate methods sent to you. Animator did pause. So now you know the animator, it's still running, it's still looking for something to change, but nothing is currently changing, so it has paused. And then if something changes, like you do a push behavior and things start moving again, it's going to say resumed until everything reaches stasis again. Now, you don't always reach stasis. In our little asteroid space game, it's never going to reach stasis because the asteroids are always flying by, constant asteroid activity. But in the flip up from the bottom, okay, it does reach stasis. So if you want to find out when it reaches a stasis, you just set yourself as the UI dynamic animators delegate, that top level animating controller thing, and it'll tell you. Now, let's combine, let's go back and fix that problem we had with the push. Okay, so we have this instantaneous push, and so we do this one push. Well, first of all, we create the push behavior. We add the items we want to push to it, just by saying right there, UI push behavior, items. Put an array of UI views that we want to push. And then we set the mode. And if we set the mode to be instantaneous right here, then when we add this behavior to an animator, okay, because we have to add it to an animator for anything to happen. When we add it to an animator, it's going to push those items, and then the animator is going to continue to have a strong pointer to it. And so it's wasted memory. It's just sitting, the push behavior is just sitting there, unused. It was instantaneous. It already pushed. It has nothing to do. So a lot of times what we'll do is we'll use that action thing to have a little closure that removes the push behavior from the animator. Okay? And since we know action gets called right after it instantaneously pushed, it's a perfect time to remove it. However, you can see that this creates a horrible memory cycle. Look inside that closure. The very first thing we do is say push behavior dot. That's going to capture push behavior. And of course, push behavior, the action var, is on push behavior. So they're pointing right back to each other, directly to each other, and keeping each other in memory. So how do we break this cycle? So I bring this example up because it shows a way to break a cycle that we haven't really shown an example of, which is to use unowned. Okay? We don't need to do weak self here, and in fact we wouldn't do weak self, because we know that inside this closure, push behavior can never be nil. It could never be outside the heap, because we're in the action method of that push behavior. The only reason we'd be here is because we just pushed with that push behavior, so it couldn't possibly be out of the heap. So it's guaranteed to be there. So we do not need to do any of this weak or anything like that. We can just say unowned. And unowned means do not keep a strong pointer inside this closure to push behavior, because I know it's going to be in the heap. You see how unowned works there? So unowned is kind of more of a force way of breaking a memory cycle, and you've got to be really sure that that thing you're going to mark unowned is in fact going to be there. Otherwise, it will crash your app. But here, we know for a fact. All right, that's it. On Wednesday, I will do a gigantic space demo to show you how all this stuff works. If I have time, which I almost am certain I will not, I'll try to work some core motion in there, which is the accelerometer and gyro and all that stuff, how we make that work. There's no Friday section this week. Next week, we're going to be doing a lot of stuff, kind of the general how things work in iOS that we haven't had a chance to cover, like the application lifecycle, you know, what happens when your application launches, runs, it quits, etc. And then things like alerts, putting alerts up on the screen, which you'll all need for your final projects. And there's a couple more segues, a little more rare kind of segues than the show segues that you know about that I'm going to cover next week as well. And you'll probably want all this stuff as you're doing your final project. So that's why I'm going to try and cover it all next week so you have time to get to it before the end. All right, that's it.
For more, please visit us at stanford.edu.